Alright, welcome back to another video by Firestarter Graphics and Engineering. Today we're going to be discussing some FEA/FEM, that stands for Finite Element Analysis or Element Method, whatever you choose. Now, basically what that is just a type of analysis that anyone can do, but engineers do it a lot. Imagine a shoebox and you draw a grid with magic marker all around it that represents the mesh, and then put a weight on top of it, and then do matrix math on each one of those little individual cells. Let's say each one was 10 millimeter by 10 millimeter. So there'd be about 1,000 of them across the shoebox. If you do the math on each one, you could figure out and sum up all the forces and figure out how much force is on each one of those cells. How much deformation and all this stuff. That's what FEA and FEM is. So, actually, FEA falls underneath FEM, CFD falls underneath FEM because you still use a mesh to do some sort of element analysis. Anyways, so today I'm going to show you some basics, and then we're going to lead into an example. So first we're going to open up an empty file. Now our example that I want to talk about later on is converting my 3D printer, that's a 300 millimeter by 300 millimeter by 400 millimeter print volume, into a into a linear rod axis system, just like Prusa. Currently, right now, it uses POM wheels because this is like a 10-year-old machine. Works great, by the way, but I'm thinking of updating it. But I just want to see how much deflection that 3-pound glass bed and frame is going to put on the bearings and on the linear rods. But first we need to cover some basics. Okay, so there's two different ways we can go about this basic shoebox example I want to talk about. The first one is going to be in the part workbench. Now, you can do this in part design and then switch to the part workbench for the last step, and it'll work. So first we're going to drop a primitive cube, and this cube, if you go to property views and then data, tell you it's 10 by 10 by 10 millimeters. That's great. Okay, so we have this cube. All right, so if we were to take it into straight like this into the FEM, this is our shoebox, okay? And we look at it and we're like, okay, we need to drop in an analysis container because every FEM needs an analysis container. It also needs a material, okay? So this material, we're going to choose aluminum. So I'm going to hit OK, and then we're going to open this analysis container. And then every analysis needs some sort of constraint. So what are we going to do? I want to glue this shoebox to the ground. So I'm going to hit add. I'm going to click this face and it adds constraints. So notice the constraints are along the entire face. That means it's glued down on that face. But if I were to click remove, come on, there we go. I'm going to hit re-add. If I were to just click this vertex right there, it's going to put it there. I could do vertex, right there and there, nothing in the middle here. I could even click this edge. Oh, only one type can happen. So, if I hit remove and then remove all those and then hit add, I can, do an edge, 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 and then would, edge. Everything's added. So there's that method, or we could do the entire face. Okay. The problem is forces work the same way. If I hit add, I can hit it there, along there, I can hit it along, can't do along the face if you're doing along the edges. Okay, so we hit remove, hit add again, click the face. Okay, this is all fine and dandy for a basic shoebox example, but remember I said we put a weight in the center. We didn't put a weight across the entire box. So how do we change that? How do we make it so we can put a point load or a weight right in the center? Well, let's find out. So we go back to the part workbench. I'm going to select this face. I'm going to hit create sketch, plain face, hit OK. I'm going to bring in some geometry. Okay, circle. This is a 10 millimeter. No, I know it says 10 millimeter by 10 millimeter by 10 millimeter, but let's pretend it's a bigger shoebox. But we're going to make, and the weight we put on is half the size of the shoebox. Okay, so 5 millimeters. Now we need to dimension that wherever we want it. I want it smack in the center. So 5 right there. And then it's crazy that I was able to get it at 4 by 4. So I'm going to hit 5. Okay, so we have 5, 5, 5. Perfect. Okay, so I'm going to go ahead and hit close. Okay, so you're going to come up to here and you notice it's still not separate faces. What is going on? Well, we got to do a little bit of magic here and some cutting. So I don't like how sometimes it puts things in between things. I want to drag that sketch above the analysis container. So we're going to click cube, control, click sketch, and then I'm going to go to this Boolean split objects thing and do a Boolean fragments. Okay, so with that, notice now everything is split. And if I highlight over this, it's not a cylinder within it, it's just a face on the cube now. So I'm gonna it's not gonna let me, I'm not gonna worry about moving. I'm gonna go to FEM. So now in the analysis container, now I really want that above. Come on, you can do it, sweetie pie. You can do it. You can. Fine. What about underneath? Oh my goodness, just underneath. That's all I want you to do. Please. Okay, thank you. All right. Open up the analysis container. Now we can add the constraints. And for this case, I want it all on the bottom. I'm going to hit OK. And then we're going to add the force of 10,000 newtons. We're going to hit add, click on that face, and we want to reverse the direction because it's a weight on a shoebox. We're going to hit OK. Last thing we need to do is we need to mesh it, but notice the meshing is not available. So if you click Boolean Fragments, that's the last thing. I don't think you can just click the sketch or the cube. I guess you can, but I'm just going to click the whole Boolean and just do that. Second order, just going to keep it at its standard defaults right now. We're not going to refine the mesh too much. I'm going to hit apply. I'm going to hit OK. I'm going to hide the Boolean fragments so we can just look at our pretty mesh right here. Not too bad, not too bad. I'm going to drop a solver in here. Do the thing with that. Okay, static. Going to do the thing with the write it and do the thing of the running. Should take less than a second. Then you'll notice, hey, that gray box thing showed up again. That is your pipeline. Where is it? Oh, I'm highlighted on it. Haha. Hit spacebar to hide it. Now, let's look at the results. Double click it. We want to look at displacement in Z. Okay. And we're going to hit show. And we're going to do this. What is its minimum? 32 microns? Okay, not bad. And now you can see how that shoebox is reacting to the force on it. So I'm going to go ahead and hit close because pretty simple use case. Now the mesh disappears because we close the results. Spacebar on the pipeline. I'm going to double click the pipeline, change the field vector to von Mises stress just so I can kind of see what's going on with the weight at that point. You can see where the stress concentrations are right along there. So, okay, pretty simple example of using FEM. Okay, I'm going to hit OK. Alright, now I'm going to show you the same method but kind of another way. So I'm going to go ahead and restart FreeCAD, so I'll be right back. Okay, I made it back. Let's go ahead and do parametric part. And we're just going to do, you can either create a sketch or you can actually, come on, there we go. And we're going to make a box. What was it? 10 by, whoa. Darg. I don't know why it does that. Sorry, I need to go to this tab. There we go. Hit close, and we're going to pad it by 10 millimeters. So there's our box. Another way of doing it is you could have done part design, create an additive primitive, additive box, and it would have done the exact same thing. But I'm not going to worry about it. Okay, so if I click this face, there's two different ways to do this. So we could do create a sketch, okay, and bring in our geometry. Perfect. And make a 5mm hole. I'm just going to center it as if I already dimensioned it. You already saw me dimension things, so I'm going to hit close. I'm not going to worry about it. So there's two options. I can go back to part, back to here, click pad and sketch, and do a Boolean Fragments, okay, so that everything is split up again. Or I can go into part design, click on the sketch, do a pocket of 0.001 millimeters, hit OK, and that will just ever so small, it's like 1 micron face right here, about the size of a human hair. So now we have separate things, and now we can go back into FEM, and I'm going to go ahead and do that same process one more time just to make sure you guys can follow it. So we're drop analysis container. Every analysis container needs a material. We're going to use aluminum 6061 T6, hit OK. Every object needs to be glued down and constrained. And then we need a force. We're going to reverse the direction, 10,000 newtons, hit add, click right there, hit OK. Every object needs to be meshed. Okay, hit OK. Back to analysis, drop in a solver, and then write the INP, run, close that error message. Yours probably won't error message. Mine's just saying, hey, you don't have a working directory. That's okay. So, results, displacement in Z. Now it's negative 31.8 instead of 32.0. Don't know why the difference. Maybe that 1 micron depth was enough to change something ever so slightly. But, similar results. Hit close, pipeline, whoops, displacement, von Mises, right there. And you can notice the pattern is just slightly different. So I wonder if it has something to do with the way that is cut. I mean, one way we could find out here is where's purge? I've seen it before. Oh, purge results. So we're going to get rid of everything here. Hit yes. Select that. Okay. Undo the body. We're going to go back to part design. Okay. Pocket. We're going to do 0.1 microns. So itty freaking bitty. Now we're going to go back to FEM. And I'm going to pause it here and then we'll take a peek at the results. Okay, so I went ahead and even made that smaller, as you notice, but still the same value. So, we're talking very, very small amount of deflection here that's not even visible to the human eye. Now, if this was for aircraft or a spaceship, could that be enough to change up designs? That's very possible, especially if something has to be airtight, but you wouldn't want two faces indexing with each other that are just pure aluminum without some sort of gasket in between to block air. So I doubt there'd be an application in airspace for this shoebox example. Anyway, so that's how you can do it in two different ways. Now this is important to know because when we go over our next example with the linear rod, there's two different ways to do it, in 1 dimension or 3 dimensions. I'm going to show both. So that'll be next time's video. So thank you for watching this one, and I hope you learned something. So not pay attention, stay tuned for the next video. Anyways, thank you for watching.